Hello friends, myself is Professor Pratik Vaksore. Today I am really happy that I am sharing this video lecture series with you because I was planning to make it since from long time, but yes, today I found time for it, and yes, I'm really happy. Okay, so without wasting time, let's begin. Okay, so this lecture series is about our unit first, which is related to the laser. Okay, and yes, today we are going to understand all the basic concepts about the laser. Okay, so as we know that the laser plays an important role in today's world or in our technology, because this laser technology is really important, because it has so many applications in various fields of our life. Okay, so the incredible uses of laser technology includes barcode scanner we see in a mall, laser printers, okay, optical disk drives which is used in a CD, okay, and cutting and welding materials in a industry, semiconducting chip manufacturing, semiconducting chip that we are seeing the mobile phone today, okay. So laser is also used in that industry as well. So law enforcement devices and free space optical communication, it is the one of the most important applications of laser. So laser is also used in DNA sequencing instruments as well, okay, surgery like hair removal products and skin treatment. So my intention is to hear that I want to tell you that laser has really so many enormous application in various field of our life. Therefore, as an engineering perspective, we really need to understand each and every topic of lasers, okay, and most importantly the physics behind of the laser, okay. So yes, let's see the in this video session we are going to understand laser with the help of these subtopics, just like introduction, importance of laser engineering and technology, what is laser actually, characteristics of laser, basic physics behind of the laser, helium neon laser and semiconductor laser, this is one of the two type of laser, and applications of laser. Okay, so we'll try our best to understand each and every topic in a detail. Okay, so let's begin with this slide. Okay, as you can see, this is the sunlight. Okay, why this image is here, because you know that the biggest source of light on planet earth is a sun. Sunlight consists of seven wavelengths, and sunlight has also so many characteristics, just like a monochromaticity. No, it is not in monochromatic in nature, but we can compare laser light with the sunlight. Okay, so the intensity, okay, so light power of sunlight is given to here, light power 10 to the power 26 watt, okay, and the intensity is given to here also in this, okay. We are going to compare our laser light with the sunlight later on, okay, and then we will compare both of the light, okay. So here is the flashlight, okay. Here is also the light power is given to us, and the power density of the laser light, and the filament lamp 100 watt filament lamp. This example is really known to us because we are using it for our home uses, okay, the flashlight. But there is a major difference between the flashlight and sunlight, okay. So laser light possesses monochromaticity, high coherence, high intensity, high unidirectionality, but the flashlight, which is the ordinary light source, which does not possesses these characteristics, okay. So what is this actually characteristics, we'll understand. Okay, here is the laser light, okay. uh, the characteristics, so power is here, 1 milliwatt power gives us a very high intensity, just like it 4 into 10 to the power 4. CO2 laser 60 watt, and also gives us a very high intensity, okay. So pulse laser is there. Ruby laser is a kind of pulse laser. What is the continuous laser and pulse laser? Okay, we'll understand it also. Okay, so what is laser? As a acronym suggests us, that is light amplification by stimulated emission of radiation. So this is the acronym of laser. Here is the given, light amplification by stimulated emission and radiation. Okay, so here is the definition given. Laser is a device which emits amplified monochromatic electromagnetic radiation using the process of stimulated emission of atoms and molecules, using the process stimulated emission of atoms and molecules. So this stimulated emission is really an important process to understand us. Okay, I'm again repeating the definition. Laser is a device which emits amplified monochromatic electromagnetic radiation using the process of stimulated emission of atoms and molecules. So what is the stimulated emission? Okay, before to understand stimulated emission, we need to understand two processes, that is absorption and spontaneous emission. Okay, absorption and spontaneous emission. Here is the characteristics is given to us, okay. just see here the properties of laser light. Okay, we'll understand the stimulated emission, spontaneous emission, and spontaneous absorption process. But before that, we'll understand the properties of laser light. Okay, so first properties of laser light is highly monochromatic. Highly, mono means single. So laser light has a single wavelength, and yes, if there is there a minimum spread is there of laser light? So answer is yes, but it is really small as compared to the ordinary light. Okay, so the spread is given here. Suppose we take an example of helium neon laser. Wavelength of helium neon laser is given to us like 632.5 nanometer, and there is a small spreading of wavelength is there, delta lambda, and which is 0.2 nanometer. So 0.2 nanometer is really less. Okay, diode laser, it has a wavelength 900 nanometer, and delta lambda, that is the spreading of wavelength, is nearly about the 10 nanometer. So it is again really small. So therefore laser light has a nearly, we say that it has a single wavelength, and therefore it is in a monochromatic in nature. It is in monochromatic in nature. Okay, so this is the first characteristics of laser. Another characteristics that laser light is a highly directional. Here is the example of our ordinary light bulb source is given, and another is the beam. Okay, so another is given is the laser beam. Okay, so ordinary light source, it has it consists of several wavelengths, and its spread is in every direction. But you can see the laser light has a very high range. It is goes up to the several kilometer without diverging. Okay, yes, divergence is there, but it is really small. It's kind of, it's will be in a fraction of degree, but it is really less as compared to the ordinary light. But ordinary light bulb, it is given to in your slide, it has a so much divergence as compared to the laser light. Okay, so even you can see this is the one of the amazing applications of laser light is to what, to measure the distance. Okay, and even we can help with the help of laser, we can measure the distance between earth and moon, and it is precisely found that 384 or 3,84,400 kilometer. Okay, so what is the distance between earth and moon? 3,84,400 kilometer. Okay, so we understood second property, that is laser light is highly directional. Okay, the third property is laser light is highly coherent. Highly coherent, what do you mean by the coherent? When we can say two waves in a coherent in nature, when the phase difference between these two waves either zero or constant. Okay, when the phase difference between two waves should be either zero or constant, and then we can say that this kind of waves are in a coherent in nature. Okay, so take an example of this light. Okay, take example of, this is incoherent waves, this is incoherent waves, but this is coherent waves, this is coherent waves. And we can see the difference with the help of image, that you can see here is the one wavelength is there, another wavelength is there, another wavelength is there, another, and these all are the wavelengths are different wave. Okay, but here you can see that the phase difference is exactly same, because maximum of one wave is falling on the maximum of other wave, minimum of one wave is falling on the minimum of other wave. So in this case, what is happening here is, in this case, constructive interference takes place. Constructive interference takes place, and constructive interference takes place due to that, we are getting, very high amplitude after the addition of all individual waves. Okay, addition of all individual waves, we are getting very high amplitude, and therefore we are getting very high intensity. So intensity is the byproduct of coherent property. Okay, and these are the really identical photons that you can see here in image. Okay, and this is one of the most important characteristics of laser light. Okay, moving toward the next characteristics, that laser light is highly powerful and intensity. Okay, this characteristics is about the intensity. Okay, so therefore this light, or this laser light, is used to for drilling purposes, or for the cutting purposes, for the cutting purposes, because at the very small area, at the very small area you can focus the laser light, and therefore it has a very high impact, it has a very high impact. Okay, so just you can see here, the laser light is used for the cutting, welding, drilling, and military weapons purposes. So it is used to these purposes because of why, because laser light is highly powerful and intense. Okay, highly powerful and intense. Okay, so another one more application of laser light is what, the laser light is a polarized. Laser light is a polarized. Polarization, we know that all the stimulating photon vibrates in the same phase, vibrates in the same phase, and this is also one more application, sorry, important properties of laser light, that laser light is a polarized light. Okay, so in our first video series we have understood about the laser, what is actually laser and what is its characteristics. So question will be asked in exam that give the four characteristics of laser and give the corresponding applications of laser, or okay, so we have covered our characteristics parts in our first lecture series. Okay, so the next processes will understand in next lecture. Okay, so till bye bye, till then bye bye.